So first of all, I'm Florian, and today I'm here to actually talk about chatbots and LLMs, large language models as well. What else can you talk about these days? But I'll start with a small introduction. So I'm the CTO at Supertext. We are a language AI company, mostly sort of focused on translation at the moment. And we are sort of, we are an engineering company in the sense that we, for example, also host our own AI models. We actually fine-tune them as well. This is why my question came up. But we also employ sort of experts, like language experts in our sense. So we kind of take this approach in between because we think something very valuable comes out of that. I guess this is also one of the gists from the previous talk from Fabio. A bit about my background before I get started. Before coming to Supertext, I did research on NLP, natural language processing, essentially the field that large language models came out of. It was quite a lot smaller back then because that was the pre-language models times. There was exactly one professor at ETH that would research in NLP. Today, it's almost any professor that does AI at ETH that sort of works on NLP. So quite a different time. Also for our company, which was quite accelerated with this hype. But yeah. Anyways, so when Rafi from 9 approached me about this talk, I read his message and he was saying, you can essentially present anything. Can be an idea, a thought, like whatever. I mean, just something that you would like to share or discuss about. And I thought, okay, what can I talk about? And regularly, my friends, also sometimes our clients, ask us one question whenever it comes about products that work with AI. And this is the one I'm trying to answer today. Can't we just use ChatGPT to solve that? Right? It's the elephant in the room. I mean, it's a chatbot that is working very well. I also think it's useful, honestly, so I was a bit surprised there. But question is, does it work on every use case? And so I'm trying to touch upon that today, convince you a little bit that this in certain cases might not be the case. So but before we do that, we look a bit at the basics. I mean, sorry for this, but this is just my background and I love it. So we'll have a quick look. I mean, those you all know, right? Those are the chatbots. This is the first one was ChatGPT. By now, there's many options. There's Perplexity. There's Gemini. There's many different chatbots out there. But the one thing that is often in the public or in the media almost used interchangeably is chatbots and LLMs. It's not the same, right? That also came up in the previous talks. Large language models are the technology that powered chatbots, right? This is the first sort of important distinction. And then let's look a bit at what these models are, okay? They are fit based on sort of finite data using sort of iterative optimization techniques. And this is important because any machine learning model like LLMs, it's essentially in a mathematical sense, it's just a function, right? And a function, if I'm telling you now, and this is the magic about machine learning, write a function that given a prompt gives you back a word and then another word, another word, another word, that's a really hard problem. So the nice thing about machine learning is that you can learn these functions from data. So if you have enough data about a problem and you can formulate an objective, then you can train a model. And this is essentially where all the power and also all the sort of challenges with LLMs come from. It is trained on a lot of data, but finite data. And because, having a function like that sort of maps words to other words, it's a really tough function, and you can't just optimize it like a, I don't know, like a parabol that you learned in high school about. So it's what you'll get is a model that is not perfect, but it's working very well in practice. And it's only trained on so much data and not on more. So the example is, if you train an LLM today, you can only train it on the data that exists up until today. Tomorrow it will be outdated. There are tricks to fix this, but it's important for understanding that it's always trained on finite data. And how does this training look? I can go a bit faster here. So as I said, the models, they have only one objective, which is predicting the next word. Okay, so you give it some text, you ask the model what's the next word. That looks like this. For example, here, Iceland's prime minister has sought to reassure the nation as it braces for a volcanic. This is the input into the model, and the model gives you back, if it's a good model, eruption. That's just sort of the next token prediction. And this training step, like you can do that with a lot of text, right? You can imagine you take all the text in the internet, and this is literally what's happening. And these models are trained by big research labs, for example, OpenAI, Google, but also universities. Like, for example, there's a Swiss AI initiative here in Switzerland. They sort of train their own base models. But this is expensive. I mean, this sort of one training run of sort of creating the next sort of GPT-03, the next Gemini 2.5 Pro, that costs millions. So only big companies can do that. But some of them, as was mentioned before, they open source their models, which is really nice. Sort of, for example, Mistral or Meta. And then you can add a step on top, which is sort of fine tuning. And for chatbots, it's actually called instructions tuning or instruction tuning, where instead of, the model essentially optimizing to just give you the next word, you show it a couple of examples from sort of helpful conversations. Okay, so the user asks a question, for example, can you give me an example of a fruit? And the pure base model would maybe give you back apple. Okay, but this is not a helpful answer in practice, because you're looking for a bit more, right? You're looking for a bit more context. So what it will give you in a helpful conversation is an example of fruit is an apple. It comes in various colors, blah, blah, blah. Okay. So this is sort of how you get the model to be helpful. All the knowledge is encoded in the first step. Second step is you get it to have a conversation with you. Yeah, I said that this is pre-training and fine-tuning. And the one thing, and this is the last sort of basic here, is hallucinations. Hallucinations are essentially errors that LLMs make. And they happen when they sort of generate factually incorrect, misleading, or nonsensical text. And tricky part is this text often seems plausible. So we have like an example here. This is an old ChatGPT version. This is actually from Wikipedia, but it illustrates the point pretty well. So the user asks, summarize this article, gives like a URL, but the LLM doesn't have sort of access to the internet nor to the article itself, and it gives you a summary of a non-existing article. And that happens because these models sometimes pick up cues from the training data. So in the training data, there was probably definitely there were some New York Times articles, right? And there was the URL at some point, and also the article text. And, based on certain keywords here, it probably like learned to, I don't know, see this, sorry. Okay, so based on that, it just picks up on some cue in that in that URL and just generates a summary, but it's just made up. And that can happen because these models, it hasn't seen this exact article in the training data. How could it be? Maybe it's newer or something. And then again, it's trained on finite data, and again, it's not a perfect model. It can make mistakes. And this is important. Those hallucinations, they don't happen a lot, but if they happen, you would want to catch them, at least if it's an important use case. So, interfaces to LLMs. I think this is this is the most important part that I'd like to cover here today. Because, I mean, the decision of whether you fine-tune a model, whether you host your own model, or just take sort of the API from OpenAI or from Google, all this depends a lot on your use case, a lot on how you kind of want to sell this, right? I mean, we do also host with 9, I guess, otherwise we wouldn't be here. So we have our own models, but this is it really depends on the use case, right? But what I think is the interesting part, especially if we talk about this question that I'd like to come back now, is the interfaces. Because I mean, my answer to this is, it depends, but if it's a target, you could probably somehow solve it with ChatGPT or any other chatbot, but it's likely not efficient. And what do I mean by that? So for me, targeted use cases are, as I said, I will touch on translation here because this is just what we do, but also programming. I think they are characterized sort of by very specific user needs and sort of that you might require feedback, or you need some sort of feedback loop from experts. And what do I mean by that? So what you see here is essentially on the left side the ChatGPT interface, on the right side Supertext interface, but you could also imagine DeepL or Google Translate or whatnot, right? And at the sort of like translation is a use case with a certain specific need. For example, you kind of want to translate from one language into the other. And you could obviously specify that in a prompt. You could say, okay, you are a professional translator, please translate the following sentences from English to German. Okay. I mean, if you had to type that every time, that would be very time consuming. And now you could say, okay, you are a professional translator, you can place that in the system prompt, in the meta prompt, that's fine. You don't have to repeat that. But then again, you always want to translate from one language to the other. Then is the question, how do you encode that? You show that as a language, sort of as a language tag to the model, or do you always have to type English, German? You don't know which languages are supported well and all that. And this is one example where you can sort of optimize your interface for the use case. By the way, it's the same with programming, right? Even if you have like if you want to have an agentic workflow while sort of developing your product, maybe your new startup, then you don't want to ask your questions in ChatGPT because you don't, the point isn't, I mean, you'll get back some code, yes, but the point is you want the agents to work on your laptop, right? You want them to create files, create environments and all that. So it's just not a good interface. And the second point is, let's imagine this use case. It's a bit of a bigger translation. And I copied that yesterday from the UBS blog, right? So maybe in marketing you figure out, okay, I have most of my text translated, but last minute I need to translate like a paragraph from, that's just missing, and we want to publish this article in many languages, so now I need to get it translated. Of course, you will get some translation back, but if you're sort of publishing that on a website with great visibility, and I would argue that the UBS blog has that because it's, I mean, in the US, in the UK, you can find like the UBS essentially everywhere. You kind of want to make sure that the text is correct. And for example, with us, you get the chance to verify your translation, to get a language expert to check essentially what the model does in sort of cases in which this is important. And I think this is, you don't have that with ChatGPT, right? You can't collaborate with experts on ChatGPT. And I think depending on the use case, that is very important. So I think that's another argument for essentially creating your own interface and your own product around this. And I see, I don't know, how am I doing on time? Good, okay. Then we can also do this how to use LLMs part here. And I agree with Fabio there, it's very, very important to using LLMs right. So you have to educate users about the utility and also the pitfalls sort of LLMs. One thing is their predictions are often correct and useful, but you kind of need to post-edit them or verify them. So, I mean, if it gives you like something like an output back, that, for example, you know the model, you weren't connected to the internet and you had like your model hosted on your server and it gives you a summary of an article that is only online, you should be very suspicious, right? It just generated something. And this is why experts need to be in the loop, and depending, like, for example, when we sort of help organizations roll out machine translation, which is essentially professional translators translating with AI, we always provide trainings. This is super important because people might just rewrite every sentence from scratch, which doesn't make sense, right? Because often the translations are correct. But then again, they can't just, hit enter and enter and enter and just accept every translation just like that. That just doesn't work. You should always, if possible, in your interfaces provide options to override by experts. Maybe that expert is already in front of the screen. We have that a lot with coding, right? Where you as the professional sort of see what the model generated, which code, and you might want to tap complete it if it sort of makes sense, or maybe it doesn't. With agents, it gets a bit more dangerous because people, even people without coding experience can sort of, prompt to get like code for an app and deploy it automatically. I think they will see the software quality sort of degrading a little bit, but I guess we'll see. And then last but not least, you should leverage the strength of the technology. And this is around context. Because the good thing about these models is they can take in a lot of context, meaning you can, in translation, for example, if you provided the whole text, it can translate all of it at once. And this is helpful because that might mean that terms are, for example, translated consistently for a whole translation, which is super important because we compared ourselves with DeepL and we figured out, we use LLMs now for a while for our translation model, and if you sort of paste something to DeepL, what happens is you have this whole text and then you see that certain terms are like translated inconsistently, while if you provide like the whole text, for us, you sort of see that the terms are consistently translated, and this is because you give the model the whole context. But you have to realize that, right? If you copy every individual segment or every individual paragraph, then it won't work. You need to you need to give the model the chance to have all the context and give you the best translation in our case. And this is sort of how we beat DeepL in sort of 3 out of 4 language pairs. But this is all. I guess they don't use like LLMs in their main interface yet, because otherwise I would have thought they score better there. But it was an anonymous A/B test, so we didn't do any cheating there. Okay. So I think we are at the end. Also of my time, anyways. I think my most important takeaways, or the most important takeaways of the talk should be, I think, different interfaces than chatbots and sort of different products that are powered by AI do make a lot of sense if you've understood the use case and if you're building it for a specific use case. And I think this is something that you can always say if you're pitching your product or your new project or whatnot to like a client or even just to your friends. you have to see if it's less work for the user in this specific use case than, for example, ChatGPT, and then I think, yeah, it has a very good chance of succeeding. Thank you. Okay. Do we have questions?
I have a question. Did you work with Watson API, and if maybe heard about it, or if and something, do you have experience?
No, we don't work with it. I assume it's from IBM, but I don't know it. Yeah.
Yes. What's your impression of the future? Like, because every time a model comes out, stuff that before was hard to get right gets easier to get right. Is that just continuing, or do you see the point where it stops?
I think it's continuing up to a point. So I mean, my point earlier was like these. I don't think it will change how these models are trained. So let's pick an arbitrary sort of quality metric. If we're now at 90%, I think we will go to 95 to 99% eventually, but I don't think we're getting to 100% anytime soon, because these models are just the way they are trained, just the way they are optimized, they will be imperfect. And the question is, how bad is the error? How bad are the cases, the 1% where it fails, right? If you're building a classification model for brain cancer, you probably want to get it right? You don't want a model failure in the one case where it would have been important to intervene.
How about security? So, for example, if I translate something using ChatGPT, I'm always concerned what happens with my data. Where is it actually going to? How about your website? If I, for example, translate my resume, what happens with that?
Yeah, if you use our free version, I'm pleading the fifth. No. So I mean, if we delete the data with if you buy one of our subscriptions. If not, we'll use it. We'll log it. We don't use it for now, but we might use it in the future for fine-tuning better models. Like the idea is that if users give feedback, negative or positive, about what they do, this is a signal to improve our models in the future.
But it's not data that what you can share with ChatGPT, and people worry about it actually. It's very...
Yeah. And we host it. We host it here, right? We host it with Nine. Like the whole model is with us, and especially if you're a corporate client, obviously we don't save any of the data. But if you just go on supertext.com and translate a little bit just for yourself, yes, that is locked. But anything else, we delete it, and we can prove that we delete it, and it actually never leaves Switzerland. So especially financial institutions, as you can imagine, work with us. So
not any policy of data saves. I don't know.
We do have a lot of policies. No, we do have that. Yeah, like we are ISO certified and all that. It's a big topic, honestly. Yeah.
Good. Thank you very much.
Thank you.